All right, let's get right into it. For the last couple of years, we've gotten used to AI as this super fast, know-it-all machine. But something huge is happening right now. The entire industry is shifting from AI that just knows stuff to AI that can actually think. We are literally at the dawn of machine reasoning.
And this really gets to the heart of it. It's a real head-scratcher, isn't it? How can an AI absolutely crush one of the world's hardest exams, an exam filled with memorized facts and patterns, but then completely faceplant on a simple riddle that a 10-year-old could solve? The answer to that question tells us everything about the difference between knowing and reasoning.
So to really get this, we can borrow an idea from psychology. Think about it like this. Today's AI is a System 1 thinker. It's all about fast, intuitive gut reactions. It's just matching patterns it's seen before. The new generation, though, is System 2. It's slow, it's deliberate, it's logical. It's the difference between just blurting out the first thing that comes to mind and actually sitting down to work through a problem, step by step. And that slower, more careful process, well, that's the key to everything.
You see, the biggest problem with that fast System 1 AI is something called the autoregressive trap. It builds its answers one word at a time, and once a word is put down, that's it. It's locked in. Imagine trying to write an email without a backspace key. A tiny mistake at the beginning can spiral into a completely nonsensical answer, and the AI has no way to go back and fix itself.
So, how in the world did engineers get around that trap? How do you give an AI a backspace key and a brain? Well, let's pop the hood and see how these new machines are actually built to think. The secret sauce is a process that happens completely behind the scenes. It's called the latent reasoning phase. Before the AI even thinks about giving you an answer, it's doing all of this. First, it breaks the problem down into smaller pieces. Then, it explores a bunch of different ways to solve it. It actually checks its own work as it goes, and only then does it pick the best path forward and give you the final answer. It's like it has a hidden internal monologue. And the way it does this is by using a kind of digital scratch pad. The pencil it uses are called thought tokens. These are all the calculations and explorations that you, the user, never see. This hidden scratch pad is where the real work happens. It's where the AI can try things out, make mistakes, and correct itself, all in private before it presents you with the polished final result. Now, with a technology this game-changing, you just know all the major players are in an absolute sprint to perfect it. So let's take a look at how this race between the titans of AI is shaping up. If you zoom out, you can see three really distinct strategies emerging. You've got OpenAI, and they're pushing for the absolute deepest, most complex reasoning possible. Then there's Google, who's focused on making AI reason about not just text, but images and video too. And then you have this disruptor, DeepSeek, who's all about making this incredible technology super efficient and available for everyone.
OpenAI really kicked this whole thing off with their O-series models. Their laser focus is on cracking the hardest problems you can find in science, math, and especially coding. And check out their unique approach to safety, deliberative alignment. This is fascinating. Instead of just having a dumb filter that blocks bad words, the model actually reasons about the safety rules and context. It understands nuance, which is way more sophisticated.
Google's big play with Gemini 3 is all about multimodality, thinking across different types of media. It can watch a video and tell you what's likely to happen next, or look at a screenshot of an app and help you debug the code. Their coolest feature has to be vibe coding. You can literally just describe the feeling or the goal of an app you want to build, and the AI just goes and builds it. It's incredible.
And then there's DeepSeek, the disruptor. They're shaking the whole industry up by making their powerful models open weight. Their secret weapon is efficiency. They've developed some custom tech that lets them deliver this amazing reasoning power while using way less computer memory and energy. That is a massive deal because it lowers the cost and makes this tech accessible to way more people.
But, and this is a big but, this monumental leap in what AI can do doesn't come for free. Giving AI the ability to actually think has some very real, very physical consequences, especially when it comes to power. Just let this number sink in for a second. A single question that requires this new, deep reasoning can use 30 to 100 times more electricity than a simple fact-based query. It turns out that thinking is incredibly energy-intensive. And this chart really puts it into perspective. A normal System 1 question barely uses any power, but a complex System 2 reasoning question, with all those hidden thought tokens firing away, that can chew through up to a full kilowatt-hour of electricity. This completely changes the economics and the environmental footprint of running these models at scale.
Of course, the hardware industry is racing to solve this problem. Take a look at Nvidia's roadmap. You can see the evolution right there. They went from chips for training to chips for efficient answers, and now they're looking ahead to 2026 with Rubin. The entire design of that future chip, especially its brand new memory, is being built specifically to handle the enormous memory requirements of these long, complex chains of AI thought.
So, we have an AI that can reason. We have hardware being built to support it. What's the end game here? The goal is to turn these amazing thinkers into powerful doers. This is the beginning of the age of digital agents. So what exactly is an AI agent? Well, it's a huge leap past a chatbot. It doesn't just answer your questions. It actively tries to accomplish a goal for you. It can use tools, like your web browser, your email, your apps, and it uses that reasoning ability we've been talking about to make a plan and then execute that plan from start to finish.
And one of the smartest ways people are building these agents is with a design pattern that's really easy to understand. Because, well, it's how we humans work. It's called the planner-executor model. Just think of it like a manager and a worker. Here's how this digital dream team works. You have the planner. That's a big, powerful, and expensive reasoning model, like OpenAI's O3. Its job is to do the hard strategic thinking, to take your big, ambitious goal and break it down into a perfect step-by-step to-do list. Then, you hand that list off to the executors. These are smaller, faster, much cheaper models that just blaze through the checklist, knocking out each simple task one by one. It's a brilliant and cost-effective way to get complicated work done. Okay, so let's put it all together now. We have reasoning models, we have the hardware to run them, and we have these new agent frameworks. This isn't just a small upgrade. This is pointing toward a radical rethinking of the future of work itself. Just imagine this for a second. Sometime around 2026, a prompt like, organize a conference for 200 people in Chicago in October. That's not something you type into a search engine. That is a job that you delegate to your AI project manager. And it will go off and research venues, contact catering, check speaker availability, and come back to you with a fully formed plan. And this is going to create a brand new economy of intelligence. Think about it. Basic knowledge work, that's System 1 stuff, like finding a fact, summarizing a long email, that is going to become a commodity. It will be basically free. The new high-value skill, the thing that becomes a premium service, is reasoning, strategic planning, creative problem-solving, managing complex tasks. That's what we'll be paying for. And that really brings us to the final big question. For all of human history, access to knowledge was the thing that was scarce and valuable. Now, knowledge is abundant and free. So what happens to our world, to our jobs, to the way we even think, when the next great resource, reasoning itself, can be bought and scaled on demand?